guest of honor is a die-hard techie and a profound open source enthusiast. He is an AWS certified solutions architect with 5+ years of experience in designing and developing cloud-native systems and architectures. He has demonstrated mastery in architecting solutions on top of AWS, GCP, and Kubernetes. As he joins us today at the DOS for the very first time, his talk will propose a solution that he has come up with at Xebia to validate all manifests of Kubernetes at the CI layer itself. With that, let's move ahead and invite onto our screens Mr. Noorain Panjwani. Here we go.
I am Noorain, your tech bud. I head the Kubernetes practice at Xebia, where I take care of solution development and accelerator development in around Kubernetes. In this talk today, I want to speak about one area where we have been investing pretty heavily in, which is policy management using OPA Gatekeeper. More specifically, shifting policy management left in today's DevSecOps era of software development. I'll just set some context. The projects that I've been working on involve, 5 of the top 10 private banks in India, setting up private banks from scratch in the APAC region and the US region. Been working with really mission critical applications. Moreover, the throughput which we see gets into the tens of thousands of requests per second. So downtime is something which we cannot really afford here. And given this context, given the scale at which we are operating, which is mostly in and around Kubernetes, there are a couple of things which we've seen and observed from where this entire topic of policy management has begun for us. So the first thing, everything we do starts with Kubernetes, right? Now, fortunately or unfortunately, Kubernetes makes it really easy to make a complete ecosystem around it, which is great. There's so many tools which make it richer, which make it far more efficient, which makes rapidly evolving and prototyping much easier for all of us. However, in order for us to reap all the benefits, we really need to make sure that we can configure them. We can make sure that all these tools can work together. And that's a really tricky piece to figure out. And this is usually where we've seen a lot of problems and a lot of downtime originating. So I want to talk about the issues which we encounter. Again, I'm just going to be focusing on the Kubernetes side of things, not particularly on the CI/CD part. So on the Kubernetes side of things, most of the issues are production delays or loss of time or energy, even loss of money in some cases, is due to misconfigurations. Like I said, so many tools need to work together. They need to be configured to work together, which might not really be an easy task to do. And it's not just misconfigurations, right? Kubernetes doesn't help us a lot in access control. It gives us some really neat RBAC features, but when you really get into the enterprise scale of things, there are some features which are lacking. And this is where the rise of policy management comes into. This is where the governance aspect comes into. How do you minimize errors due to these two reasons? So before we talk about the solutions, I just want to give you some examples of some simple ones which we've seen so we can all come on the same page, right? So misconfigurations. Let's talk about single resource misconfiguration. I'm sure you're all aware that in Kubernetes, everything is configured using these config objects, right? To make a container, you need to run a pod. If you want to run a pod in a more reliable fashion, you need something called a deployment. You need a service object for network identity. And all of these are different objects which you need to configure. It's a very declarative form of configuration. Some of the misconfigurations we see in these objects is, if you see this first example, which I have for you, running a pod as not a root user, because that's a big security risk if you run it as root. You want to avoid it. And if you can see here, in Kubernetes, you can define the security context to restrict this in 2 places. One is in the spec, which you see right here, and the other is in the container section. Now, you need to make sure that it's present in either one of these places. You also need to make sure and understand that there are some levels which are going into the play here. Like the container context on the container level, the security context in the container level is going to override what you specify on the pod level. Now, this logic needs to be understood. So even if you describe a pod to be non-root on the pod level, but override it on the container level, you're in for a problem. right? And these little minute details need to be known ahead of time by the people configuring your Helm charts or configuring your Kubernetes resources. On the other hand, a simple example would be liveliness probes. We all know that just checking if a process is running isn't enough. We need to make sure that we have some healthy probes in place for doing health checks. We want to recycle probes which are not working. We want to recycle probes which are just halted for any reason. And we need to make sure that the liveliness, the readiness, maybe even the startup probes are in place to do that. And maybe you have a policy that there are only a certain set of probes which you want to do. Like you may not want to use the exec probe, but just the HTTP probe. Maybe you do not want to allow the use of a TCP probe because that's too basic. So these all are policies which your organization is defining as a best practice. Maybe misleading, but a good practice, right? But these were the easy problems. These are still something which can be debugged and solved. It takes time, but it can be solved for sure. The bigger problem which we've seen is in multi-resource configuration. Let's take an example. Whenever you are configuring a deployment, which is basically how you run things in Kubernetes, you most probably will run it with an autoscaler, which is the HPA, right? The horizontal pod autoscaler. And I think you are aware of this, that when you're using an HPA, you're not supposed to define the replicas field in the deployment because that will override the horizontal pod autoscaler scales, right? So these two cannot be present together. So based on whether or not you have a horizontal pod autoscaler, which is a completely different resource here, the config of your deployment is bound to change. Now, this is dependencies between two configurations. There are multiple examples where this happened. This is just one of the common ones and the common errors which we see, which causes a ton of downtime. Let me share a practical experience here. So we had a pod which was auto scaling, and let's say it was scaling, it was running on 10 replicas, right? Because it was running during peak load. Now, for some Canary deployments, for some tests which we wanted to run internally, luckily this was in the staging environment, we reapplied the configuration, but the replicas field was set to 1. So what happened is, as soon as the CD pipeline ran, our deployment scaled down to 1. And because one pod wasn't enough to take all the load, our system crashed. And unfortunately for us, that was the most mission critical part of the app, which caused a downtime for running our automated tests and caused a big backlog to happen for us. On investigation, we found out that, hey, the replicas field was set, which was an easy fix, but it's difficult to figure out what's going wrong. Why are things failing? You have to go through the entire audit logs to make sure that these things are right. And this is just one of the cases. Let's take another one. If you have ever used EKS and you've used EKS with the ALB controller, right? The way you define routes or the way you define your ingress points is using the ingress object, right? Now, there are so many things which get into play here. For example, if you want to run a load balancer on the public network, or if you want to run a load balancer on the private network, you need to make sure that you're providing the right subnet IDs. How do you make sure that somebody did not accidentally put the wrong one? Moreover, if you have two ingresses watching on the same host, you will have unexpected behavior. So now you need to make sure that out of the 10, 20, or maybe even hundreds of ingresses which you've defined, no two can have the same host name. Also, what if somebody accidentally exposes an internal app? So based on the label which is present in one of your services, you need to make sure whether an ingress is even applicable for it. Now, these are some security consideration which goes into play when you're defining all these resources. It's very easy to make an ingress object, but the consequences of making one could be dire. So we want to avoid such things, right? The last one I want to share is regarding Istio. I'm a huge fan of Zero Trust networks, to be honest. And I use Istio for achieving that. Istio is a service mesh for those who are not aware. Istio gives us a neat feature of disallowing all network traffic by default. So no pod can talk to any other pod. Now you see where I'm going with this. Your pods would have to talk to other pods. And for that, you need to make an authorization policy. If someone forgets to make this or accidentally deletes it, all communication will halt. And because of the way Istio works, the error messages are really cryptic. It doesn't really say where the error is happening. You really have to get into the access logs. And again, this is a distributed microservice architecture we're speaking about. So access logs of 30 microservices to figure out where your problem is, where the problem would be as simple as you missed out or accidentally deleted one resource object. The point which I'm trying to convey here is when you go in the documentation of Kubernetes or all these tools, the resource objects make sense. You understand how do you configure them. But based on some nitty-gritties of whether the application is scalable, whether it needs to be exposed or not, the behavior, the way you configure them really differs. And expecting each and every DevOps engineer or each and every developer to know these fine details, to know these nuances, is expecting a lot from them. There needs to be a better way in which we can catch these errors before they reach your production environment. In fact, you can catch these errors before it can reach your development environment. And that's where OPA Gatekeeper comes in. OPA Gatekeeper is basically an extension project of the OPA project, which stands for Open Policy Agent. If I'm not wrong, it was built as a rule engine for API servers. But now, because of its flexibility, it's evolved its use cases to a lot of other domains, including Kubernetes. So OPA Gatekeeper is OPA fine-tuned to work with Kubernetes. Think of it that way. But OPA in general, that's a CNCF project which you can use for anything. And that's a big point which I'll be coming back to. But just remember, OPA is the umbrella project and Gatekeeper is the extension built for Kubernetes. One other thing I just want to add, which I'll also show you really quick, is that OPA uses something called a rule engine using Rego. So you need to write some code in order for this to work. And I'll come to it really quick, but I just need you to know this before we continue. So how does this work in the Kubernetes context, right? So like I said, you're writing all these rules in Rego, which is the OPA language of writing rules, right? So how does it work for Kubernetes? Well, normally when you're using Kubernetes and you do something like kubectl apply or you run helm install, what essentially happens is that you're technically talking to the kube API server, which upon receiving those objects or those requests, it persists them in etcd, which is your state management system, right? Now, OPA acts as an admission controller. What this means is whenever a kubectl apply command is run and it hits the API server, all requests will first be sent to your OPA Gatekeeper controller, right? Using something called, as I said, the admission controller webhook. More specifically, the validating admission webhook. So your request comes in from your kubectl apply or helm install. It comes to kube API, but instead of storing it, it's now going to go to OPA Gatekeeper. Now, since OPA Gatekeeper knows exactly what you're going to apply because that's what's present in the request, since it's running in the Kubernetes cluster and it can see what is there in the Kubernetes cluster already, it uses these objects to run its rules. Then it returns a reply with a yes or no, depending on whether that request is allowed, whether it's making some violations or not. If all is good, only then would kube API go forward and persist that configuration. Otherwise, kubectl itself will return an error. So it kind of acts as an extension to Kubernetes as well. Now, Kubernetes seems to have the power to do validations of policy, which is great if you think about it, because now you don't have to change your CD pipeline at all. You're still using kubectl or helm install or whatever fancy tools you use these days. But now you have policy management built into it just transparently, which is one of the most exciting part of OPA Gatekeepers, in my opinion. Enough of theory. Let's have a look at a quick demo to see how OPA really works. Let's try to see it in action. So I'm going to head over to my VS Code and let's go through how OPA really works. Let's see what are the things you need to do to make it work. And this is the point where I get to scare you guys for a little bit. Okay, don't worry, that wasn't the plan, but that's what usually happens when people check out OPA for the first time. This is Rego. I know what your first thought is. Like, Noorain, what is this alien language you're showing us? I understand and I accept that OPA can be a slightly confusing language when you are looking at it for the first time. It's slightly counterintuitive. It's not like a traditional programming language at all. But trust me, it's specially designed for writing rules. This makes it highly customized and it really makes it so much easier to write complex policies. But in this policy, I don't want to get into the technical details, but there are just two things I want to highlight for you guys. The first is this little object right here, input.review.object. Remember, I said whenever Kube API gets a request, like a deployment object or a pod object, when it reaches OPA, when it reaches your Rego script, this is where the object will be contained. So if this was the deployment, you can understand that, deployment has a spec which would have containers. So whichever object is being applied, its corresponding object, you would get in your Rego file in this particular object, input.review.object. But if you look around, you'll notice that there is another input which we can use. which is called input.parameters. Now, this is a cool thing about OPA, which I probably should have addressed earlier. But what OPA can do is it understands that policies may differ from environment to environment, right? For example, this is a policy which I'm showing you for the blacklisting image tags, like which image tags are not allowed. For example, my production environment disallows the use of the latest tag, whereas my development environment allows it. Maybe there are some known bugs in my services in a certain set of versions which I want to blacklist. Those goes in, that can go in my list as well. The point is, the policy is still just disallowing tags, but you want to customize its behavior based on the environment. And OPA gives you this first-class concepts by initializing what we call a template. So whenever you write a regular policy in OPA, it's not technically a policy, it's a template. So you have your deployment object which comes in here, but you can customize the behavior of this policy by the inputs you can give. And you can describe the type of the inputs or the parameters right here. As you can see in this particular template, I have an input called tags, which is an array of string. So it's a string of the disallowed image tags, which I want to blacklist. So how do you initialize the policy then? I mean, this is a template. This will technically not do anything because it still needs the parameters, right? Now that's where the other resource comes in. So whenever you make a constraint template, it's going to make a new CRD for you, which is called the Kubernetes disallowed tags. I mean, I can define my CRD name right here. And in my policy is where I can pass my parameter right here. So the flow is you install OPA Gatekeeper. That is the first step. There are help charts to do that. You make a template. You may or may not define some parameters for that template. Just installing a template is not going to do anything, right? You need to initialize the template by making a constraint, which I've done here. And the constraint is where you pass the parameters. And you can also pass some match rules. Like, for example, this particular policy, which I want, should only apply for deployments, for stateful sets, and pods. Maybe I don't want to do it for daemon sets, or maybe I could add daemon sets. But it shouldn't apply for things like config map because this policy is not really meant for that. This is a good little feature, you can just use for filtering resources. You can even do filter based on the namespace, based on the labels. There's a whole bunch of things you can do. And another interesting thing you can do in your constraints is define the enforcement action. What I essentially mean by enforcement action is what behavior should execute when this policy fails. Do you want to deny it? Do you just want to throw an error? Or do you just want to leave it with a warning? Or maybe, you want to do nothing. You just want to keep that policy and just log the error in the background. There are a couple of enforcement actions to choose from, but most likely you'll be choosing from warnings to deny. These are most people usually do. Great. So I already have a cluster running for us. I've already installed the template. I've already installed the policy. My policy disallows the latest tag. So now let's take a dummy deployment, right? I have a dummy deployment right here. As you can see, the image it's using uses the latest tag, which shouldn't be allowed according to the policy I've initialized for this cluster. So let's see what happens when I try to do it. So I'm going to do kubectl apply -f deployment.yaml. Let's apply typos. Let's try it again. You can see that kubectl returned an error which it normally doesn't, right? See that it's returning an error from the server saying forbidden, meaning this action is not allowed because some admission webhook, which is our gatekeeper, has denied the request. And it's also giving us a nice little console message saying why is it denied. So again, like I told you, my CD pipeline, kubectl apply or helm install will undergo absolutely no change. But now, if any resource was misconfigured and we have a policy to catch that misconfiguration, it will get caught and we'll just we'll just prevent those misconfigured resources from being applied to the cluster at all. And based on the examples which we already saw earlier, this is affecting all parts of Kubernetes. We're talking about quality of service. I think we'll have to just rewind for a bit. I got a message there. Okay, I'll continue. The best part about this, like I already mentioned, is that when you do kubectl apply, it just works the same way. There is absolutely no change in your CD pipeline, which is great. It's a transparent action. It just works out of the box for us. So this is the demo I've got for you guys. Now let's go back to the presentation and see what we have in line next. So OPA Gatekeeper is great, but I still have one problem. The problem is, that's me, the developer. This is what I think of myself as, trying to be funny. The developer checks in his manifest or his code, right? He's going to check in his deployment config and Helm charts or whatever. You might run some CI just to run some basic Helm validate commands maybe, but the error will only come in your CD pipeline. And since I have experience of running with banks, CD is too late in the pipeline. You can't, because our CD pipelines are heavily gated, getting approval to even read CD takes a lot of time. So waiting for misconfiguration checks to happen after or in the post CD phase is something which is unacceptable. That is still not solving the purpose of saving us a lot of time. It does make debugging a lot easier because it's going to catch these errors up front, but it's too late in the CI/CD process. We need quicker feedback cycles. And that's where I have another demo for you. Remember, I told you that OPA is an umbrella project which can do anything. It's just a general purpose rule engine. And it's a general purpose rule engine written in Go, which means I can make my own rule engines using OPA. And that's what I've done for you guys. So what I have tried to do is emulate the OPA Gatekeeper action in a binary. Now, this is the binary you could run in your CI process directly. So what I'm doing here is still working with the same template. I'm just extracting the Rego file from the template, getting it here. I'm extracting the parameters from my constraint file, which comes here. I'm extracting the deployment file, which I just showed you, which is right here. And finally, I just evaluate the Rego policy. Of course, there is some boilerplate code, which I'm not showing you guys, but I have all of this in the GitHub repo. I'll share the link. You can just go and check it out and play with it for yourself. But the point is, I am really trying to duplicate or emulate the action of OPA Gatekeeper in my Go code. So now, in theory, I can have violation checks on the CI layer or even my UI layer while a person does it for much quicker feedback cycles. In OPA, thanks to it written in Go, it makes it so much easier for me to do it. So let's really check this out in action. I've already built this binary. So all I need to do is run command. And you see it can catch the same violation message which we saw earlier, right here. Now, if I fix this deployment, let's say I have a hypothetical version of 0.1.0. Let's save this file, run it again. Now, I just made a CLI tool which I can plug into my CI system and make sure that my CI checks for policy can run on every PR. And that's the power which OPA gives me. And it doesn't end here. Like I said, OPA works anywhere. You could have even used it in your API servers. You can use it across your organization, which makes it a very cross-functional tool or skill, if you ask me. Now, before I end this presentation, there's just one last thing which I want to run you through. Why OPA Gatekeeper? I know there are some other policy management tools like the tree. There are tools like Iverno, which are amazingly well. In fact, the tree works on the CI level by default. It's great. And there's even Conftest, which is another kind of extension to OPA Gatekeeper, which you can potentially use. But why is this the approach which I recommend for you guys? First, Rego is super, super flexible. The kind of cross or multi-resource constraints which you can write with OPA, it's not possible with the tree or Kyverno, the last I checked, right? I think OPA is the only tool which can allow you to, write this cross multi-resource kind of policies. Moreover, Rego can work for your API servers as well. So if you learn how to write Rego policies, you can make your rule engine for your business cases. It really helps. It's all written in Go. So you can really extend OPA Gatekeeper very easily, like write your custom auditors, which can run in the background periodically, collect metrics from OPA, send it to Prometheus, plug in OPA policy violations to your observability platform. You can visualize all these errors. I mean, it's so much that you can do with OPA just because it's open source and it's got a very library-centric and a very open DNA to it. So these are the primary reasons why I have personally adopted OPA Gatekeeper in my organization over something like the tree. It's flexibility. I can write really complicated policies with ease. It's multi-resource configurations. I can touch base or, I can use multiple different resources in a single policy, which I have not seen any other tool to do. And you can use it cross-functional and it's in Go. Whatever is in Go, you need to use it, right? That's it from my side. I am Noorain, your tech bud. You can follow me on Twitter. You can check me out on LinkedIn. If you liked this presentation, and I do similar things on my YouTube channel, which is Backstage Architects, do hit a subscribe if you like this. That really helps a lot. And don't forget, I am your tech bud here on this digital platform and hopefully someday in real life. Thank you so much.